What if I told you those iconic Atari beeps and glitchy game sounds can come back to life using nothing more than the 555 timer, a breadboard, and a handful of cheap parts? Hey guys, in this video, I'll show you how to make an Atari Punk Circuit with the 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 2 alligator clips, 22 jumper wires, 2 1 million ohm potentiometers, 1 kilo ohm potentiometer, 1 470 ohm resistor, 1 kilo ohm resistor, 2 0.01 microfarad ceramic capacitors, 1 red LED, 2 555 timer ICs, a 9-volt battery buckle connector, a 9-volt battery, 1 5-watt speaker, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and stable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 0.01 microfarad ceramic capacitor into pin 2 or trigger in the negative rail. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor into pin 2 or trigger in pin 7 or discharge. Insert a 555 timer 2 rows below the previous 555. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Insert a jumper wire into pin 6 or threshold and pin 7 or discharge. Insert a 0.01 microfarad ceramic capacitor into pin 6 or threshold and the negative rail. Insert a jumper wire into pin 3 of the first 555 and pin 2 of the second 555. Insert a jumper wire into pin 7 of the first 555 and a few rows below the second 555. Insert a jumper wire 2 rows below the previous jumper wire and the positive rail. Insert a jumper wire 2 rows below the previous jumper wire and the positive rail. Insert a 1 million ohm potentiometer into the same rows as the 3 jumper wires. Insert a jumper wire into pin 7 of the second 555 and a few rows below the potentiometer. Insert a jumper wire 2 rows below the previous jumper wire and the positive rail. Insert a jumper wire 2 rows below the previous jumper wire and the positive rail. Insert a 1 million ohm potentiometer into the same rows as the 3 jumper wires. Insert a jumper wire into pin 3 of the second 555 and the right side of the breadboard. Insert a jumper wire 2 rows below the previous jumper wire and the positive rail. Insert a jumper wire 2 rows below the previous jumper wire and the positive rail. Insert a 1 kilo ohm potentiometer into the same rows as the 3 jumper wires. Connect the positive power rails together. Connect the negative power rails together. Bend the ends of a 470 ohm resistor. Insert a 470 ohm resistor into the positive rail and the left side of the breadboard. Insert a red LED into the same row as the resistor and the negative rail. The cathode is in the negative rail. Insert a jumper wire into pin 3 of the second 555. Attach an alligator clip to the other end of the jumper wire. Insert a jumper wire into the positive rail. Attach an alligator clip to the other end of the jumper wire. Connect the alligator clips to a 5-watt speaker. It's time to connect the power supply. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. We have successfully completed the circuit. Turn the knobs on the 1 million ohm potentiometers to adjust the sounds. Turn the knob on the 1 kilo ohm potentiometer to adjust the volume. Let's dive into the circuit and break it down step by step. This is a classic Atari Punk made from two 555 timers. The battery is a 9-volt, the top rail is VCC, and the bottom rail is ground. R1 and the LED are just a power indicator, so you know the circuit is alive. The 555's job internally is simple. It watches a capacitor voltage and flips its output when that capacitor crosses 2 built-in thresholds, about 1/3 of VCC and 2/3 of VCC. The left 555 is wired as an stable oscillator. Its timing network is VR1, R2, and C1, connected to the key timing pins, pin 7 and pin 2. Here's what happens over and over. C1 charges through the resistors toward VCC. When the timing node rises to about 2/3 VCC, the 555 flips state and turns on its internal discharge transistor at pin 7, which gives the capacitor a path to dump charge through the resistor network. When the capacitor voltage falls to about 1/3 VCC, it flips back again, the discharge transistor turns off, and the capacitor starts charging again. This repeating charge-discharge creates a square wave at pin 3. Because VR1 is huge, 1 million ohm, this left oscillator is intended to be in the slow range from clicky pulses up into choppy buzzes, and VR1 changes how fast those flips happen. The right 555 is also set up as an stable oscillator, but it's meant to run in the audio range so you can hear it. Its timing parts are VR2 and C2. C2 charges and discharges between 1/3 VCC and 2/3 VCC. The right 555 output at pin 3 flips high, low, and that output is what ultimately drives the speaker. VR3 is simply a series volume limiter between the 555 output and the speaker, reducing current and softening the loudness. The output of the left 555 is connected into the timing node of the right 555. When the left 555 output is high, it pushes that node toward a different effective voltage condition than when it's low. The slow square wave from the left chip keeps forcing the right chip's timing capacitor node to shift, which changes when the right 555 thinks it has crossed 1/3 and 2/3 VCC, and it changes the effective charge-discharge behavior. That means the pitch of the audio oscillator changes abruptly in sync with the left oscillator. Instead of a smooth sweep, you get hard jumps between pitches. Those are the steps that create the retro game console style beeps and growls. VR2 mostly sets the bass pitch of the audio tone. VR1 sets how quickly the circuit switches modes or changes notes. VR3 is your loudness control, but it's also acting as a safety resistor so the 555 isn't trying to dump too much current into the speaker. I hope this video has shown you how to make an Atari Punk circuit with the 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.